1. up with side booster shutdown and separation.
Inside shutdown. Side boosters. Beacon. Center.
All right. Hello friends. Welcome back. If you're with me earlier, with me now, then thanks for dropping by. Thanks for tuning in. We have been working on cracking the coding interview in Rust. We are on chapter 2, problem 1, linked lists. We got through not very far in the first problem. Spent about 4 hours trying to implement a linked list in Rust. It's a little tricky, a little trickier than I thought. Had I known it was going to be so tricky, I probably would have researched it a little greater in detail beforehand. But anyway, you live and you learn, right? Best way to learn is to just get out there and try things, do things, get things done, make it happen. All right, well, let's go ahead and continue, pick up where we left off. If you're new to the series, new to the stream, then I invite you to check out my GitHub profile where you can find the code for this and a bunch of other things I've worked on. A little about me. My name is Brenden. I have been writing software, working for startups and so on for, I don't know, the last 15 years or so of my life. This series is about practicing coding problems and doing it in Rust, learning Rust at the same time. I'm not really an expert on Rust yet, but I'm trying to get there. I'm doing it by taking on these interviewing problems and trying to solve them without cheating, at least not cheating too much, without just simply looking at the solutions. So, you know, we're learning as we go, and that's that. So, yeah, I was just reviewing some other other example implementations. There's one here, which, does this run? Can I run it? Cool, it does. There's one here, which is kind of similar to what I've done. This is actually what I was trying to re-implement initially, and I kind of got sidetracked, sort of went off on a down into some rabbit holes and lost track really what I was doing. I like this implementation. I like it because it's using these reference counted pointers, but there's another implementation which is from this, I don't know what you call this, blog post, Learning Rust with Entirely Too Many Linked Lists. There's several different implementations of linked lists in here, and the author of this, whose name is, I'm not sure, it's not here on the front. Probably A. Binges. Beignets. Anyway, this is an example. Following pointer types. I wonder if persistent. I wonder if they Oh yeah, see this one uses reference counter pointers. Anyway, I would like to get this, I'd like to just get this done. Or at least get the basics working. I'm just looking through this code. This one seems so comparatively simple to what I have. Interesting. So the thing that is a little different in this versus the way I did it are the two things. One is that this guy's wrapping iterators in another structure, which is nice. I like that. I think I might take that from this. Another thing is that there's a separate structure for the head of the list, which is also pretty sweet. I like that. I like the way it's done. It's clean. It seems clever. So I'm gonna borrow that from this. Borrow the good bits. So let's go back to my implementation, which I think is kind of garbage. And I'm gonna change some things. Let's just rename this to oh great, that doesn't work. Let's rename this. Change all occurrences. Oh man, what did node? Okay. I'm gonna rename this to node ref. All right, then I'm gonna add another struct. What's going on? What on earth? I have two cursors. I was in multi-cursor mode. Okay. Add a new struct here. This is going to be my actual linked list for type T. And this is just going to contain a pointer to the head. That's going to be an option with a node ref. Should probably specify a lifetime for this. Yeah. Okay. That's cool. It's similar to what we got over here. Yeah, it's a little different because, yeah, he's just using an RC. So I'm actually not sure I understand this ref cell thing, and I have it in here. So I'm just gonna remove it because there's no RC, or there's no ref cell in this version. I started using that because when I was digging through the Rust documentation, there were references to it that seemed to suggest I needed to be using that at the time. But all right, whatever. I'm paring it down. I'm paring this down to just the basics. Just the basic stuff that I need. Okay. I just want the bare minimum right now. All I'd really like to be able to implement at this point is an iterator. That is all I want. It's all I want for Christmas right now. Excuse me. Okay. Another thing I'm going to borrow from this is an iterator implementation like this. This seems like a good idea. Yeah, just like that. I don't need this to be public. Next option. All right, let's see if I can get this compiling. I'm also just gonna start removing code until it's compiling and everything is happy. I'm just gonna remove my garbage iterator implementations because they don't work. Gonna get rid of this because I don't think I need that. Expected lifetime parameter. I don't understand why that seems necessary. Where am I? Add. I'm just going to delete this. This is new. This should be new on. Well, this should be on the linked list. New initial value, self, head, none. I'm going to get rid of this initial value parameter. Okay, does that compile? No, doesn't compile yet. 17. I don't understand why. Well, let's add that there. No. Error is never used. What on earth? What on earth is going on? Line 4. All right, let me just get rid of this. Whoops. Line 5. This needs a undeclared lifetime, but if I add the lifetime here, it blows up. A is never used. A is never used. Unused parameter. I don't think that matters. Like, why are you complaining? All right, I think that's fine. Let's move on. So, how do they implement append here? Public function append element t, return a list. Okay. List head, sum, element, next, self head clone. Okay, I understand that. So, let's do that over here. So append, what I don't like about that is that append appears to allow you, actually, this is interesting. This is nice because it looks like what append is actually doing is an insert. Right? Except that you could, so no, it's not really appending. If this were a proper append, then it would only apply to the tail of the list, right? But as I understand it, it's not necessarily doing that. All right. Well, let's see what I can do here. Append. I'm trying to understand. So it's basically constructing a new list, which is this, and it returns that list. And it does so with the head set to a new element. And see that's weird. I don't like what it's doing there, honestly. Append shouldn't, if append is going to return a list, it should return the list is being passed in, modified in place. But I understand why it's being done this way. It's being done this way because trying to change it, change things, trying to change like mutable function parameters in Rust is kind of tricky, as I have discovered recently. So I assume that's why. Looks like maybe, I don't know, I haven't read this whole thing or like understood all the code yet, but if I were to guess, I think they may be avoiding doing that for this purpose. So I guess what I'm saying is that in order to keep track of the head, you would have to actually keep track of the original head. So you're making like a new list here, and then a pen, and then yeah, like your head, your new head becomes something else, as I understand it, because like it's essentially list equals list.tail. I'm actually super confused by how that works. Tail, head is ref, and then node next clone. So list new, pen. Set mutable iter equal. Oh, I see. So this is not actually appending to the list. This is actually pre-pending to the list, right? Because it adds 1, 2, 3, and then in the test you can see he's getting 3, 2, 1. Also, I guess this is perhaps not meant to be a linked list. Like, I mean, what is he actually? Yeah, this is he's calling it a stack. So I get that. I get it now. Makes sense. Okay. I'm not going to do that though. I don't want to do that. I would like to preserve the head. So, all right, this is fine. New, and then add self. I'll just return a new list here. So this should be implemented on, yeah, linked list. Why is VS Code broken again? Let me try restarting it. It's really nice when the formatting stuff works. It's not working. Why does it break? Output, debug, terminal, problems, RLS, restart the RLS, update the RLS, updating. I'm updating it. It says it's updating down here. The whole thing's twirling. Is that good? Think that might be good? I don't know. We'll see. RLS is Rust language server, by the way. It's a daemon that comes with Rust that provides some tooling, I guess, for working with Rust. Restarted it. Is it working? I don't think it's working. Quick start, install Rust up, install this extension from Marketplace, open Rust project, configuration, show warnings, all targets, features. This is cargo, blah, blah, blah. Is my Rust language server running? RLS is running. It's right there. 6:15. It was just started. But it don't work. It don't work. It's possible that I have my settings with the format on save disabled. No, format on save enabled. Is it disabled for Rust for some reason? No, I don't believe so. Workspace settings. What? Modified? Why are these modified in the workspace? Modified in user. Workspace settings. Wait a minute. Maybe this is where the confusion is. Let me wipe my workspace settings in VS Code. Where does it hide its files? In source, bin. That's super weird. Workspace settings. I don't have any workspace settings here. Format on save. Modified in user. Show matching extensions. Huh? I want that on. Reset setting. What am I working on? Hello, R2DBC. I'm working on a Rust project. Specifically, I'm going through this book, Cracking the Coding Interview, and I'm solving the problems in Rust. Although for a moment I was trying to fix my editor, but kind of lost hope on the editor. I may just give up. Okay. There we go. Formatting worked. So, all right, add, self, new. When I do this, I'm just gonna create a new one of these, and the head will just be the same self head. And I'm going to change add to append to make it clear what it's doing. Yeah, Java's a little easier than Rust. Rust is a little tricky. I think all of the, or most of the official answers in this book are written in Java. I think if you were actually, doing a coding interview, it would make a lot more sense to use Java or Python or something. Rust is probably not the best language to do it in, frankly, because of the trickiness. But anyway, okay, append. I'm gonna run another function here to give me the tail. Tail self, and that's going to return a node. Yeah, node. Should I return a node or a node ref? Good question, me. I think it should return a node. Yes. Okay. Tail. Let's look at how they did it here. So to get the tail, they are, it runs on the JVM. No, Rust does not run on the JVM. Rust compiles down to machine code. There's a Rust compiler. Compiles to C code. Or to machine code. It's similar to like C or C++ in terms of the level it operates at. It's meant to be a system programming language. The compiler I'm using is Rust C. It's called Rust C. Okay. Let's get the tail. List head, self head, and then node next clone. I'm not sure how that would do it. Am I on mate? I don't know what mate is, to be honest. Debian. I'm using Mac OS. This is Mac OS. Okay. Append. Self.head. Let me just see if this compiles. Cargo test. Expected type. Did you mean iter? No, I meant item. Why are you doing this? Can I find type item in the scope? I have type item right here. Type item. Why are you being difficult? Self. I'll change this to self. Primary is never used, unused, unused. Okay. Consider removing A or using markers such as std marker phantom data. Don't know what that is. Okay. Append to the list. To append, need to go to the tail. And tail is going to return a node. Node of the same type. And to get there, I will simply say, I'm gonna look again at this. So tail in this is literally just like taking the head, and then head does what? List, this returns a list, and this returns an option T. So I'm not even sure I understand, like, this doesn't even necessarily make sense. I don't think this is really what I want though, because I need my list to be mutable. I need to be able to modify it in place. This one uses box into iter. So what does it look like to push an element on this one? Yeah, this is kind of what I'm trying to do, or similar to what I'm trying to do. Except I'm using RC. Hey Goku, hey. The link list is going, it's still going. Trying to do it a different way. I'm using this too many lists thing as my guide, and hopefully I can get through this. All right, so here I need to is my API full 8 DE or text editor? I'm not sure what you're asking. If you're asking about my text editor, I'm using VS Code, Visual Studio Code, which is, you know, it's the hot new thing these days for now. I like it. It works. All right, well, let some node equal interesting. So this box node, mutable node, I see what they're doing. So this should be the current node, then current node equals yeah, the next node. I see what they're doing, yeah. Yeah, I like IntelliJ too. I've used IntelliJ a fair bit. Also, I'm pretty sure you can run VS Code on Linux. I haven't used Linux as like a desktop environment for a long time, I will admit. Oops, it should be next. And the reason for that, my story for not using Linux is not very interesting, and I used it for a long time, for like many years, and then for a long time I didn't own my own computer. I didn't have my own computer. The only computer I had was what my employer had given me up to then. Like, I didn't have any money. I couldn't even, you know, afford to afford to buy a laptop. You know, like not within like the past like 5 or 6 years, but before that. And so actually the first job I got where I was given a MacBook and I had to use a MacBook was when I got a job at Airbnb. And I actually installed Debian on my Airbnb MacBook, and I had it on there for a while, but then eventually I had to give up on trying to run Linux on a MacBook because they like switched to some new type of Wi-Fi authentication system or something, and I could no longer connect to the Wi-Fi, so I had to install Mac OS, and that was it. I basically gave up hope or whatever at that point, and I don't know, I've basically just used Macs ever since, and that's what I'm used to now. And I don't know, I guess at this point I just use whatever, and except for Windows. I can't use Windows. Windows is just completely unusable in my opinion. Alright, what did I just write here? I'm just like looking at some code and copying some stuff, talking, but alright. So current equals head, and then while let some immutable node current equals next. So I'm trying to get this doesn't work because this will go past the end. What I'm trying to do is get to the end of this thing. This is really not what I want. What I want is current dot next dot take, right? Can I just do that, I wonder? Cargo format? Then I should be at the tail, right? And then I can just say current. Well, let's blah blah blah. And then this should be a node. Right? Does that compile? Nope. Because it's not a node. That's an option of a node ref. This is not what it returns. Although I should just return a node ref. Or no, I'm or like I think this take, that should like expected one of, why? Oh, what on earth am I doing here? That's not right. Okay, expected one type argument. Unused type parameter, whatever. I actually don't understand why it complains like that. 4 and 10. Whatever. Okay, so tail. I think that will give me the tail. Let tail equal self.tail. Yeah. And then here at this point, I basically need to I need to update the tail with a new node. So create a new node, and my new node can be a pointer like this. And then new value like that. And then next is just none, right? Right, that doesn't work. Node, there we go, maybe. There we go, okay. I think that's sort of right. Linked list, node. That should have the lifetime specifier in it though, I believe. Though I don't understand why these errors are here. Code, you're talking about like the like putting the coding errors or whatever in the IDE. And yes, it does do that normally, but the Rust integration is not working right now in my VS Code, and I can't figure out why. I'm trying to like restart it and stuff. Yeah. Anyway, I don't really want to figure it out right now. I'm just gonna have to deal with it. Okay, so I think let me just get rid of this code because it's crap. This code's crap. So I want a new list. Let list equal list.new. Like that, and then list.pen. Item 1. Linked list, my bad. Yeah, IDEs are pretty nice, pretty handy. I like VS Code. I think I was saying before that I've used IntelliJ quite a bit, but the only problem with IntelliJ is that it's just so flippin' slow comparatively, like really slow. I'm gonna remove these lifetime guys because no, why does that not? Undeclared lifetime. Perhaps it's like, oh, you know what? Yeah, it's probably like this. Right? Right? No. Unused type parameter. Okay, if I do that, are we happy? Still unhappy. Undeclared lifetime. Literally have like, I guess it's not the same. Might really, let me just try this without. What is my main programming language? I guess I get asked that question surprisingly a lot. I don't know. I don't really have a main programming language. It's definitely not Rust. I don't use Rust like in my day job or anything. Most of the time I'm using like scripting languages, Python, whatever. In my particular job, we use a lot of Java. We use a lot of Ruby. I don't know. I've kind of used everything at some point, though. Everything, not everything, but like the most of the popular whatever languages. But not Rust, not yet. I haven't really had a chance to use that. Option, next, option. I see, it's blowing up here. Okay, so this should have a lifetime parameter because this is a reference. Yeah, I get it. I get it. Using the linked list book, yeah, I am following the linked list book. I kind of gave up, and I'm trying to use it. I don't think what I was doing was working. Still not there yet. Mismatched types. Yeah, right. Okay, I'll come back to that. 35. While. No field. I can't do that. While equals current equals node dot next take. Yeah, right? There we go. Okay. And 33. This is returning expected type. Yeah, this should be an option. Cannot move out of borrowed content. Oh man. As mutable as it is. Why have I wound up here again? Self needs to be mutable, it must be. But I'm not. In this case, I'm not mutating the list. I am just yeah, I need to just like read read through the documentation and like books and stuff on this so that I can properly understand it. Although I also just want to get this working and like at least finish the first problem. Once I get the first problem done, then I'll go back and reread it so I understand. So my understanding of take is that takes the value out of the option, leaving none in its place. I don't actually want to do that though, right? Like, that doesn't sound right. All I want is a reference. Can I just do as ref? Head dot as ref. What happens if I do this? That seems better. Take requires a mutable reference. It makes sense. Okay. 30 head dot take. This should be mutable because I'm actually modifying that. Cannot borrow as mutable. Oh, yeah. Self iter last. I don't think I can use iter last because I haven't implemented the iterator for one. It's sort of here, but it's not done yet. Yeah. I have to actually implement the iterator to do that, I believe. I'm just trying to get like the absolute basic thing working yet, like a list with a couple of items appended. That's it. Item 1, item 2, cargo format. There we go. So let me see. All right, let me see if I can get the iterator thing. So the thing I didn't do last time, which is something I totally missed, I'm kind of used from like the way that you make an iterator in something like Python where you use a yield statement. I guess I've been sort of spoiled by that. You can't do that in Rust because anyway, let me finish what I'm saying, but you can't use that yield in Rust. You have to basically keep track of the state of where you are, and the way that they're doing this in this example is they use a struct explicitly for iterating, basically. And I'm going to copy this pattern. But yeah, there are a ton of people coding on Twitch. I only started doing this like 3 or 4 weeks ago, like trying to code on Twitch, and frankly, I'm amazed that like anyone wants to watch me like trying to figure out how to write Rust. But yeah, whatever, it's pretty cool. And there's like other people I've been watching other people on here too. It's pretty cool that there are people doing this. Anyway, okay, so I'm gonna copy this pattern here. It's like into iter, where it's basic. You can yield in Rust. Yes, I think you have mentioned generators to me in Rust before. However, I think this is a topic that might be like, yeah, nightly. It may also just be like slightly beyond beyond something that I can grasp right now in Rust. So I'm gonna try to just implement a basic iterator. So I'm gonna copy the pattern they have here with their iterators. Let's see if I can do that. So I need these structures, these structs. Yeah, I already kind of did this. So this is mostly the same, except called this linked list into iter. So I don't need these to be public. Okay. I wish that the Rust language server would actually work properly. That would be super sweet. Or at least work in VS Code, because it's not working. If you have references across yield points or yield references, you get into memory pinning and memory unpinning. Yeah, that sounds annoying. Okay. Struct, blah, blah, blah. I think this should actually maybe just compile as it is. Nope, not quite. Cannot borrow as mutable. Node mutable. I think I have to do like as mutable, or as mute on this, right? Or borrow mute. No method, borrow mute for hold on a sec. No method, borrow mute for type std rc no t. Oh wait, I'm already doing this. Head as mutable map node. Can I just return the node at this point, actually? Expected struct node found. Okay. Can I do this? As mute, no. Method as mutable exists with following traits are not satisfied. So I believe the problem is that getting a I basically want a get mute. I want a mutable version of that guy, right? This is an associated function, not a method. I see. Expected type, mutable node t. So essentially I just need to like unwrap this guy again. Right. Although, yeah, because I have like an option of an option. Can I just do unwrap? Sweet. Okay. That seems to have worked. I don't know if that was the right thing, but compiler is letting it happen. Let me just add some statements here. Well, hold on. Let me see if I can iterate over this. Let's try it. For x in list. Debug. It's not an iterator. What? Thought I just implemented my iterator. Apparently I didn't. So oh, I see. I need to actually implement the iterator piece. Excuse me, which I did not do. Into iter. Next. So this, I believe I need both of these. All right, well, thank you for stopping by R2 DBC. Hope you learned something, maybe, maybe not. Okay. Data self 0 pop. I didn't implement pop. I'm not sure if I need to implement pop. What does pop do? Take care. Bye-bye. Pop. Let node. So pop looks like it's basically just getting the head element. It's just getting the head element out of the list. Right? Okay. Option, self-item. Let node equal node self-head equals node next node element. Into iter list into iter. I get it. So into iter is just provided, I think, as a convenience. So I'm not actually going to implement this because I don't care about it. I'm just going to make the trait iterator is not implemented for, yeah, it is. I think, no. Oh, I do need a mutable iterator. Okay. Iterator. Well, I know why. It's because I need to call iter on it like that. Sweet. There should be node.data. Cannot borrow as mutable. This I need to do like this. RC get mutable node dot unwrap. Here, can I just do node dot get ref? No. I just want a reference. Can I just... Expected node found struct RC. Yeah, so how do I just return a reference? Can I just borrow? No. Returns contained value. How do I get a reference to this guy? Rust get reference to RC. This brought me back. Brought me back to the same place. In reference to object parent RC, function borrow, explanation, possible solutions. Possible solutions. You can just turn the ref object to be blah blah blah. I think yeah, I didn't think it was going to let me do that. Okay, hold on. Pup, what are you doing in there? What are you doing? What are you doing? No. No. My dog's just going crazy right now in the bedroom. You're making a big mess. Okay, no more. She's destroying stuff. All right, I'm back. Yeah, okay. Next, as ref, map node. Can't I just unwrap this guy? No method unwrap for RC. Try unwrap. RC try unwrap node. Expected struct. Found a reference. Node next as reference. Can I not just expected reference found enum result? Sounds like I need to unwrap it again. Man, this is too crazy. How is what I'm doing so different from this? Asref. Next asref map. Node. Expected reference. Found enum. Hello, I am very smart. I'm glad there's at least one of us here that is very smart. Because I'm definitely not. I'm maybe like medium level smartness at best on a good day. Maybe like houseplant level smartness. Can't even get this code to work. All right, this is not working. So the only thing I'm doing differently is that I am using a reference counted pointer RC instead of a box, which is what they use here. They're using a box. So I'm not totally sure why this is not doing what I think it is, what I think it should be doing. So this should be, yeah, self next map node. So this should change. I should change the node to the next to like the next node, right? And this is just a reference here. So like self.next. Yeah, unwrap and then map node. Method map exists for node T in the current scope. Expected struct node found node of T. Expected type found type. So I should just be able to deref that guy. Boom, there we go. That seems to have worked. Cargo test. A test is ran. It is not printing anything, which means I think it is not working. Must not be working. Cannot be working. 4x in iter. Excuse me, I just sneezed. Sorry, would have muted my microphone if I'd known I was about to sneeze in time, but it happened so fast. Node.data. Just adding some more statements here to hopefully, maybe be able to print a thing. Format. C cannot be formatted with the default formatter. Blah, blah. Okay, that's super annoying. 4x. I'm just curious as to whether or not it gets here. Pup, what are you doing? You're going crazy. Nope, no crazy stuff right now, please. It's not even printing that out. It's never even getting there. This doesn't print. A doesn't print. X doesn't print. Beginning to think my iterator doesn't work. Head as ref map. I don't think that's right. I think it should just be like that, right? Expected, found. Self.head. Puppy's going crazy. I see. So this guy, this has a node ref. And then this is, okay, I see. These are different. No, I didn't mean to change that. Leave that. I meant to change the iterator, this guy. Did I do that wrong? I'm making it worse. Go back to what I had. There we go. Struct is never constructed. Use variable. It's not working. Okay. Am I doing something wrong here? Print. Hello. It's not even printing my hello. How about here? Does it print my hello? Where's my hello? Is my test not running? Run test. Oh, there we go. Cargo test. Test list has duplicates. I don't understand why that happens. Okay, whatever. Hello. Okay, it is going. Into there. So something's not right with my iterator because it's never entering into this next. Let's see. It's replying to a message there. Okay, my list still doesn't work. Let's try and figure out why the F it's not working. List.iter. So it goes into this function and it should be returning this iter structure thing, which if I just run this manually, list.iter .data, if I just print that, a new field, iter dot this returns iterator, so it should be iter dot next dot unwrap dot data. Yeah. No data on type blah blah, blah option. So yeah, it should be what? Listener next dot map node dot data. Cannot move out of borrowed content. Ah! Alright, that did something. Equals none. It's none. Well, there we go. That's why. Why is my list.iter returning none? Let's look at my list implementation again. So what does append do? So new, creates a new list, whatever, okay? Append creates, oh, it's because I need to basically, I need to assign actually, I just need to return self here. Right? Or this doesn't need to return anything. Map node, that still returns none. Chapter 2, problem 1. Man, what am I missing? I'm just gonna put this code into my main here, so I can run it like this. Cargo run C02 P01. dash dash bin. Plus dot da 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 is equals 9. Why is that none? Cargo format. Plus tail equals self.tail. I think my tail implementation might be broken. That could very well be. Debug P. Debug. Cur. Can it be formatted? It's super annoying. Okay. Let me just try to figure out what this is doing. So, current equals head as ref. There should be a reference to head here. Okay. So then I'm saying while some node equals, I think this should be next, right? While let's I'm going to do this slightly differently. While this is going to, yeah, this is going to go past the end, right? No, it isn't. It should stop because current, yeah. So this should be okay. Tail, new node. Oh, you know why? It's because I'm not actually updating the tail, right? I need to say tail. Tail next equals new node, right? No next on no unwrap. Some new node. Cannot assign. I need a mutable yeah, this needs to be a mutable ref. Types differ in mutability. 44, yeah. Expected type, option, mutable, found type. I basically need to do like I need a derefed version of that. How do I get a, oh that's right, RC as mutable. Yeah. Oh, it's get mute, not as mute, get mute. Expected mutable reference. Ugh. Unwrap. So this is an option to a node ref. Yeah. Current equals blah, blah, blah as ref. So option get mutable. What text editor is that? I'm using Visual Studio Code. So I think this guy is already, I think the issue is this needs to be what, like as mutable? Is that a thing? Expected type, found type. Okay. We're on to something. Cannot borrow as mutable. Of course not. Oh man. I'm at the point almost where I just want to like copy and paste all the code from the other one. Seems like it might be the only way to do this. Not really. I'd like to just figure it out so I understand. Tail. Cannot borrow as mutable. 42. Why can I not borrow as mutable? Tail. All right, let me go back. Let me go back to this one, this book. Where is it? Opaque, push. So what happens if I just take this code? Although, so thing I'm not sure about this stack, or the stack implementation. There's a few things that I'm not sure about. One is it's implemented as a stack, which is not really what I want. I guess I could probably fix that, but I also wanted to use, instead of box, I really wanted to use RC, but I'm beginning to lose hope on the reference counted pointer. I just am not sure that drop iter peak pop box RC. Yeah, I haven't tried that. Boxing RC. I don't know. Box ref cell. So yeah, I already tried using ref cell, and I couldn't make that work. You know, sort of had it working, but not working. Working, but not working. Let's see. Kind of forget what state I'm in right now. What was I trying to fix? I was trying to fix tail here, because I think the problem with my tail was that it wasn't if you go to LeetCode and do most of their grass tree problems in Rust, they pretty much use box RC. I'm using RC, but not with box. And I can try that. Why not? Why not? Box RC. That's gonna break all my existing code, but we'll figure it out. Okay. Let's fix these one at a time. 39. So tail. What am I trying to get here? So I would be happy with a node ref here, like that. Expected type, found type. Yeah. Unwrap. Expected node. Okay. I think we're kind of getting somewhere. Cannot borrow as mutable. 42. Here. Cannot borrow as mutable. Why can he not borrow as mutable? Return a pointer an RC from tail. Return RC node T, you mean? Like this. So I don't have to unwrap. Well, okay. Whoops. This is an option though. So that is why I'm unwrapping. I can just do this. Right? Shouldn't map unwrap this for me? I just do unwrap? No. Expected, found mutable, reference. Also, that's boxed again, so like I have to like double unwrap it. Don't I? No method in current scope. How does one unbox a box? Rust box. No. Don't destroy the floor, please. Please. Dereference. Expected, found struct. I need it more unboxed. More derefed. Okay. Still not right. Cannot borrow is mutable. Okay. As ref. Cannot move out of borrowed content. Ah. Pup. Pup. Don't destroy the floor, please. No destroying the floor. Thank you. My dog is... she's trying to destroy the floor right now. I think she's bored. She needs to go out. I gotta probably call it quits for the night soon. Hi, pup. Hi, pup. Might have to do some bedtime reading and just read over read over the documentation stuff. I do have this in a repo. If you'd like, I can check this in, even though it's not working. Let me just get it into a state where it will compile. And if you want to take a look at it, I'm just going to undo. Actually, I'll just leave this as it is, and I'm going to check it in. Git diff. And it's going to break the build, but I don't think that's a big deal. All right. Cargo test. Yeah. So this is chapter 2, problem 9. Just for anyone following along, I'll just hold up the book here. The problem I'm trying to solve is, let me switch the camera here. The problem I'm trying to solve is right here. Focus, please. Focus camera. It's not focusing. Come on, focus please. Come on. Well, problem, there we go. Okay, remove duplicates. Number 1, write code to remove duplicates from an unsorted linked list. Follow up. How would you solve this problem if a temporary buffer is not allowed? So that's where I'm at. Haven't gotten very far on this problem, trying to implement a linked list. So if you want that, you can screenshot it or something. I will check in this code in a moment here, push it up to the repo. It's going to break the build, but so be it. Yeah. If you take the time to practice these problems, you'll probably do well in coding interviews. Way she goes, I guess. I really wish that like a book like this had existed like, I don't know, like 10 years ago, when, at least for me personally, I hadn't seen all the problems at that point, and was not so skilled at interview problems. A book like this would have made my life a lot easier then, I guess, had I known about it, and had I known that these interviews were mostly about practicing the problems until you kind of memorize all the different patterns and whatever. Anyway, all right, I gotta take my pup out. I gotta feed her dinner. I haven't fed her dinner yet, and take her to the park. And I'll probably do a bit of reading on my own on this, and hopefully get problem 1 solved. Once I understand these different types and pointers and everything in Rust, I think I'll have a better time at this. But anyway, thank you for watching. Thanks to everyone who helped out, went along. I don't know if it was as frustrating for people watching this as it was for me trying to do it, but anyway, that's the way it goes. It's what a lot of programming is. I think like some people might have the belief that programming is like easy or whatever, but I think most of the time you end up just kind of like banging your head against the desk for hours, and then eventually you realize like what's wrong and what the problem is, and you're like, oh, of course, so easy, if only. And anyway, but I guess that's part of the fun, is the feeling you get when you get to the end and you've found the solution, and you get that satisfaction in solving it. Anyway, thanks for watching. I'll probably be back on tomorrow, continuing, picking up where we left off, I guess. Thanks everyone. Catch you later. Bye-bye.